All right, today we're jumping forward into section 6 of chapter 8. Notice we're solving rational equations now. So far we have simplified rational expressions. We've added them, subtracted them, multiplied, and divided them. So the only thing left really to do is solve equations involving them. Okay, basically that means we're solving equations that have several fractions within them. All right, now there's a couple ways you can do this, but I think the best way is to begin by multiplying both sides of the equation by the least common denominator. Doing so will eliminate all of your denominators, and therefore you won't be working with fractions anymore. Okay. Now notice the directions on this first problem. I'm asked to solve, and then it says to be sure to check that your solutions do not lead to division by zero. Sometimes when you're solving a rational equation, some of your solutions at the end, they'll need to be thrown out. They're extraneous solutions because when you try to plug them back in to the original equation, they will lead to division by zero in your denominator. So that's just something added that we have to look out for. Okay, so notice this first equation. There are three rational expressions within it, and the denominators are x, 2x, and 2, which means the least common denominator here is 2x. So I'm going to begin by multiplying the left side by 2x over 1. And since this is an equation, whatever I do to the left side, I have to do it to the right side as well to maintain balance. Okay? All right, so since the left side has two expressions being added together, this 2x is going to have to kind of distribute into them, okay? So here's what that setup will initially look like. I'll have the 2x over 1 being multiplied by the first fraction of 3x minus 4 over x, and then plus that 2x over 1 again being multiplied by the second fraction of 3 over 2x. And then that's going to equal 2x over 1 multiplied by 1/2. All right, so notice the use of color here. Anything that's in blue comes from the original equation, and then red is just that common denominator that I'm multiplying by. Okay. Now, before I actually do any multiplication here, I am going to reduce what I can. If I chose actual common denominator, then that means all of my denominators should completely reduce to 1s. So this is going to become a 1. That'll become a 1. That'll completely wipe out to 1. So will that. And then the 2's here will wipe to 1s. Okay. So what I'm left with now, I have 2 times 3x minus 4 plus 1 times 3, or 3, equals 1. And I think we can agree that is a much simpler equation to solve now. So now I'm going to distribute this 2. Combine the negative 8 and the 3. Add 5 over, divide by 6, and I'm ending up with x equals 1. Now, before you circle that as your final answer, just double check. You want to plug it in. You don't have to do a full check here and actually plug into every part of the equation, but you just want to make sure that when you put 1 in to here and to here, any of the denominators that have variables, you just want to make sure that they don't zero the denominator out, which is not the case here, so that means 1 can be kept. That's my answer. Okay, moving forward, another example. Here, the common denominator would just be x minus 4, right? It's the only denominator between the various fractions here, so I'm going to multiply this side by x minus 4 over 1, and I'm going to multiply this side by x minus 4 over 1. So initially that will look like x minus 4 over 1 times negative 5 over x minus 4 plus x minus 4 over 1 times 1 equals x minus 4 over 1 times 2x over x minus 4. Okay, now do your reducing here. These are both wiping out to 1s. And these are both wiping out to 1s. Okay, so what I'm left with, I have a negative 5 plus x minus 4 times 1, or x minus 4, equals 2x. Again, much simpler equation to work with now. So now I have x minus 9 equals 2x. Or that's, let's see, I like my variables on the left side. So negative x equals 9. X equals negative 9. All right, and I think we can agree that if I were to plug negative 9 in to either of these denominators, that's not going to zero them out. So this should be able to be kept. Okay. All right, one more example here. You can see the common denominator is x plus 1. So I'm going to multiply both sides by x plus 1 over 1. So that's going to lead me to x plus 1 over 1 times x minus x plus 1 over 1 times 3 over x plus 1 equals x plus 1 over 1 times 3x over x plus 1. All right, now reduce what you can before you start multiplying. These reduce to 1s. These reduce to 1s. All right, so what I'm left with, x plus 1 times x, I'm actually going to write that as x multiplied by x plus 1 minus 3 equals 3x. Okay. All right, so now I will distribute here. I end up with x squared plus x minus 3 equals 3x. And notice we are being led to a quadratic equation here. Remember, it's been a while since we've been solving quadratic equations, but typically we like these set equal to 0, so I'm just going to subtract the 3x over. That should give me x squared minus 2x minus 3 equals 0. And then we could try to solve this by factoring. If factoring didn't work, we would use quadratic formula. This one does factor. X minus 3, x plus 1 equal to 0, and I end up with two solutions, x equals 3 and x equals negative 1. Okay, now make sure we check here. If I were to plug 3 in to either of these denominators, they would not equal 0, so the 3 is good. But notice if I were to plug the second solution of negative 1 in, negative 1 plus 1 is, of course, 0. You would be dividing by 0, which you can't do. So this is an extraneous solution. Cross it out, and you're only going to keep x equals 3. Okay? All right, your turn. Go to practice 1. Pause the video, work through it on your own, and when you're ready, come back, check your work.